Next about a 5-mark question. It is about Froth flotation process, zone refining and magnetic separation process. Froth flotation is frequently asked. And then about electrolytic refining. Regarding electrolytic refining, that is the purification of metal by the process of electrolysis. You give an example for the purification of silver, where silver is said to be purified by taking pure silver as the cathode, impure silver as the anode, and acidified silver nitrate solution as the electrolyte. These 3 points are most important. And எது நமக்கு வந்து cathode, எது anode, எது electrolyte, அது எழுதினாலே நமக்கு போதும். And then on passage of current, pure silver is deposited. இதை நமக்கு வந்து about electrolytic refining. இந்த Froth flotationலாம் வந்து உங்களுக்கு தெரியும். அது எதுக்கு applicableனா சல்ஃபைடு ஓர்ஸ்க்கு மட்டும்தான் applicable. It's applicable for sulfide ores. Principle பார்த்தீங்கன்னா ஜென்ரலாக ஓர்னாலே ore is said to be associated with some gang particles, that is mud particles. Here the principle here is sulfide ores are concentrated by Froth flotation process, where the sulfide ores are wetted with oil, whereas the gang particles are wetted with water, and that is the principle. You write the depressant, what is the role of collector, and if there is what is a frothing agent used here. If you use these terms, that's enough, and draw the necessary diagram. That is about Froth flotation process. Magnetic separation process. Here in this process, the best example is the tungsten, where it contains ore, the impurity which is wolframite, where we can purify by magnetic separation process. Coming for p block elements, when you come for the case of p block elements, similarly you will be p block elements is comprised of p block element 1 and 2. Here regarding this boron family, here in this case, what is the anomalous property of the first element of p block? That is small size, high electronegativity. These are the reasons for the different property that is to be exhibiting by the first element in the p block series. You see the case of nitrogen. Nitrogen is said to be a gas, whereas others are said to be solids or semi-solids. Nitrogen is said to be a gas. It's different from other elements. We know nitrogen is said to be triple bonded, whereas phosphorus is said to be single bonded. Then coming for arsenic, antimony, bismuth, they are metalloids and we have the metal. Regarding nitrogen, here high electronegativity, that is the main reason, small size, and hence it forms triple bond. Triple bond is said to be formed between nitrogen, and hence it is said to be different from other elements. Regarding the uses of borax, just to go for that one, ethyl borate test. Regarding ethyl borate test, the test for borate radical. Here regarding this borax, it's mainly used as a flux in metallurgy, and it's also used for the identification of metal radicals. That is the main use of this borax. When you come for the case of ethyl borate test, that is the test for borate radical. Here, when any borate radical or any borate salt is said to be heated with ethyl alcohol in the presence of sulfuric acid, here there is the formation of triethyl borate, where this triethyl borate is said to be burning with or gives a green edged flame when shown in the Bunsen burner. That is about ethyl borate test. You write the necessary equation, that is BOH thrice plus 3C2H5OH on heating in the presence of sulfuric acid concentrated we get triethyl borate, that is BOC2H5 thrice. That is the formula for triethyl borate. Now regarding catenation, when you come for the case of catenation, and before that just you go for the uses of boric acid. Boric acid is said to be used as the main use, is said to be used as a food preservative, that is the main use, and it's also used as a antiseptic and used as a eye lotion. That is about the uses of boric acid. Now regarding catenation, what is catenation? The ability of an element to form bonds with other elements, to form a long chain of compounds, that is called as catenation. We have studied in organic chemistry itself regarding carbon. Carbon has a tendency for catenation because carbon, the valency is said to be 4. If the number of valence electrons is equal to 4, it can neither gain electrons nor lose electron. It can share only electron, and hence it forms long chain compounds, that is called as catenation. Now, what are the conditions? Yes, any two conditions for the process of catenation. That element should have the ability to bond with other atoms. That is the first one. The bond that is to be formed, it should be strong when compared to the bond with other elements. That is self bond, carbon carbon. That self bonding should be strong when compared with other elements. And here regarding these catenated compounds of carbon are said to be inert towards other molecules, and that is about the condition for catenation. Next about regarding AlCl3 and TiCl3, aluminum chloride and titanium chloride. So here, which is said to be more stable? When you come for the case of aluminum chloride, due to inert pair effect, aluminum chloride is said to be more stable when compared to titanium chloride. That is enough. That is the reason why aluminum chloride is more stable. The reason is it is inert pair effect. Next about how boron nitride is said to be obtained. That is said to be a standard question. Any boric acid combines with ammonia, there is the formation of boron nitride. Next about burnt alum. If you want to know about burnt alum, you should know about potash alum. What is potash alum? K2SO4, Al2SO4 thrice, 24H2O. That is called as potash alum. From alum stone treated with sulfuric acid, we prepare this potash alum. On heating strongly, what happens means all the water of crystallization is removed, where we get anhydrous potash alum, that is called as burnt alum. Next about the action of heat on borax. When you come for the case of the action of heat on borax, here borax on heating we get sodium metaborate, that is the thing. Na2B4O7 on heating we get NaBO2, that is sodium metaborate. Yes, the next one. And another question is about the action of heat on boric acid. When boric acid is heated to 373 Kelvin, we get metabolic acid HbO2. When this metabolic acid on heating to 413 Kelvin, there is the formation of tetraboric acid H2B4O7, and this H2B4O7 on heating to red hotness, there is the formation of boron trioxide. That is the action of heat on boric acid. It's not given the question, but an important one. The action of heat on boric acid. Boric acid on heating, we get HbO2. That is called as metaboric acid. Metaboric acid on heating to 513 Kelvin, we get tetraboric acid H2B4O7. This on heating to red hotness, we get boron trioxide. Next, about differentiate graphite and diamond. When you come for the case of graphite and diamond, it's a standard question. Here, regarding this graphite, it is sp2 hybridized. It's said to be hexagonal. Diamond it is tetrahedral. It is said to be sp3 hybridized. Graphite is softer. Diamond is said to be hard. Yes, softer van der Waals forces. That is the main reason for the graphite to be a soft compound or soft form of carbon. Here, this graphite, we can also say that it is said to be used as the graphite. அது எதுக்கு யூஸ் பண்றாங்கன்னா மேலா ஒரே பொருளாக பயன்படுத்தப்படுகிறது. இதான் நமக்கு வந்து the main use of this graphite. Now coming for the uses of silicon and boron, it is a standard. I can go for this one. Next about another question regarding borax. The aqueous solution of borax is said to be alkaline. Why? Because when borax is subjected to hydrolysis, it gives a mixture of sodium hydroxide and boric acid. Sodium hydroxide is said to be a strong base. Boric acid is said to be a weak acid, and hence we say that the aqueous solution of borax is said to be alkaline. Borax கரைசல் வந்து ஒரு alkaline, பேசிக்கா இருக்குது, ஒரு காரமா இருக்குதுன்னு சொல்றாங்க. என்ன ரீசன்னா போராக்ஸை வந்து நீரார் பகுத்தலின் போது நமக்கு போரிக் அமிலமும் சோடியம் ஹைட்ராக்சைடு ஒரு ஸ்ட்ராங்கான காரமும் ஸ்ட்ராங் பேஸ் வலிமை மிக்க காரமும் கிடைக்கும். அதனால வந்து இந்த போராக்ஸோட சொல்யூஷன் வந்து இட்ஸ் டு பி alkaline. Next about inert pair effect. Inert pair effect is நமக்கு தெரியும் NS2NP126 is the general configuration for this p block elements. இதில் inert pair effectனா அந்த electrons in the p subshell alone is involved in chemical combination. Electrons in the s orbital or s subshell is not involved in chemical combination. அதனால we say that effect is called as inert pair effect. p subshell electrons மட்டும் chemical combination உட்படும் s orbitals உட்படாமல் இருந்ததுன்னா அதுக்கு பேர் வந்து மந்த இணை விளைவு. That is called as inert pair effect. Fluorine exhibits -1 oxidation state. In a reason, because fluorine is the most electronegative element. That is the main reason where it exhibits only -1 oxidation state. Reaction of chlorine with excess of ammonia. Here, when ammonia undergoes reaction with chlorine, where ammonia is in excess, then there is the formation of ammonium chloride. இதே நமக்கு வந்து ரிவர்ஸ் எடுத்துக்கோங்க. When excess of chlorine இருந்ததுன்னா, then there is the formation of NCl3 an explosive. NCl3 explosive. Chlorine excess இருந்ததுன்னா நைட்ரஜன் ட்ரைக்ளோரைடு ஒரு எக்ஸ்ப்ளோசிவ், ஒரு வெடிமருந்தாக ஒரு வெடிமருந்து உருவாகிறது. அதே நமக்கு வந்து அமோனியா எக்ஸஸாக இருந்ததுன்னா, now regarding the reaction of ammonia with chlorine, that is when excess of ammonia combines with chlorine we get ammonium chloride. So அதிக அளவு அமோனியா குளோரின் வினைப்படுத்தப்படும் போது அமோனியம் குளோரைடு உருவாகிறது. அதே போல when you come for the case of excess of chlorine யூஸ் பண்ணீங்கன்னா, with excess of chlorine ammonia gives NCl3 which is used as a explosive. Next about the difference between white and red phosphorus is said to be a standard one, just you go for that one. Then regarding uses of chlorine, interhalogen compounds. What are interhalogen compounds? When halogens combines together, there is the formation of interhalogen compounds. Example, bromofluoride, bromopentafluoride, iodine heptafluoride, these are the example for this interhalogen compounds. Now, white fluorine is more reactive than halogen. I have said fluorine -1 oxidation state exhibit பண்ணுது. என்ன ரீசன்னா மோஸ்ட் எலக்ட்ரோநெகட்டிவாக இருக்குது. ஸோ மோஸ்ட் எலக்ட்ரோநெகட்டிவாக இருக்குது ஒரு ரீசன். அடுத்தது ஃப்ளூரின் மாலிக்யூலுக்குள்ள அந்த பாண்ட் டிசோசியேஷன் எனர்ஜி வந்து லெஸ். த பாண்ட் டிசோசியேஷன் எனர்ஜி ஆஃப் ஃப்ளூரின் இஸ் செட் டு பி லெஸ் அண்ட் ஹென்ஸ் வி சே தட் ஃப்ளூரின் இஸ் செட் டு பி more reactive than other halogens. Just to go for the reducing property of sulfur dioxide. How bleaching powder is prepared? Regarding bleaching powder, that is to calcium hydroxide, that is lime, to silicate lime. If bright chlorine is heavily passed, then there is the formation of this bleaching powder. CaOH twice plus Cl2 gives CaOCl2, that is about the formation of bleaching powder. Uses of helium. Next one. Next, another important question is, it's not written here, about the reaction of chlorine with sodium hydroxide. Here, with cold sodium hydroxide, here there is the formation of sodium hypochlorite, NaOCl. When chlorine combines with cold sodium hydroxide, we get sodium hypochlorite, NaOCl. அதே நமக்கு வந்து when chlorine reacts with hot sodium hydroxide, there is the formation of chlorates. Here it is sodium chlorate, NaClO3. இதான் நமக்கு வந்து the reaction. Chlorine with sodium hydroxide, cold condition na, here there is a formation of NaOCl. Sodium hydroxide in hot condition means we get NaClO3. This is sodium hypochlorite and sodium chlorate is said to be obtained. And regarding the balance equation, Cl2 plus 2 NaOH gives NaOCl plus NaCl plus H2O. This one is said to be the balance equation. Then you come for the case of hot sodium hydroxide, 3Cl2 plus 6 NaOH gives NaClO3 plus 5 NaCl plus 3H2O. This one is said to be the reaction of sodium hydroxide with chlorine in hot and cold condition. Very important question. Next about regarding the shapes and hybridization of the compounds. For example, you see about xenon tetrafluoride. What hybridization? Hybridization கண்டுபிடிக்கிறதுனா xenonோட valence electron what it is 8. எத்தனை attachment of atoms இருக்குது 4. 8 plus 4 12 by 2 equal to 6. 6 na it is sp3d2. இது நமக்கு வந்து hybridization of xenon tetrafluoride. bromopentafluoride na bromine 7. எத்தனை attachments 5. 7 plus 5 12 by 2 equal to 6. sp3d2. Similarly we can do for xenon fluoride. Here xenon difluoride. Xenon difluoride na 8 plus 2 10 5. It is sp3d hybridization. Idha vandu how to decide the type of hybridization. And standard question IF7 oda what is the hybridization? In IF7 iodine we have 7 electrons. 7 plus 7 equal to 14 by 2 equal to 7. 7 na the hybridization is sp3d3 and the structure is said to be pentagonal bipyramidal. The structure is said to be pentagonal bipyramidal. This is said to be a frequently asked question. Pentagonal bipyramidal. Next about regarding transition inner transition elements. And before that, what is the oxidation state of oxygen in fluorine? What is the oxidation state of oxygen? This is X plus 2 into minus 1 equal to 0. X is equal to plus 2. That is the oxidation state of oxygen in OF2. Similarly, for the compound Cl2O3, what is the oxidation state of oxygen? Or we can say you have calculated here, do for fluorine. 2x plus 3 into minus 2 equal to 6. 2x minus 6 is equal to 0. X is equal to plus 3. So regarding chlorine, it is said to be plus 3 is said to be the oxidation state. Regarding HOF, what is the oxidation state of oxygen in HOF? Hydrogen plus 1 plus oxygen X, fluorine minus 1 equal to 0. Up X is equal to 0. The oxidation state of oxygen in HOF is said to be 0. Regarding this next chapter about transition inner transition elements. When you come for the case of transition inner transition elements, the general configuration is said to be n-1 d 1 to 10 ns 1 to 2. This one is said to be the general configuration for the d block elements. That is called as transition elements. And the second question, why transition elements exhibits variable oxidation state, forms complexes, forms coordination compounds. That is, complexes and coordination compounds both are the same, and then it acts as a catalyst. What is the reason? Here, regarding variable oxidation state, here the energy difference between Ns and n-1d are said to be very close together, and hence it mainly exhibits variable oxidation state. The energy difference between n-1d orbital and ns orbital are said to be very close to each other, and hence it exhibits variable oxidation state. Now, next about how to calculate the magnetic moment. Regarding the calculation of magnetic moment, we know the formula for magnetic moment is mu is equal to root of n into n plus 2. Mu is equal to root of n into n plus 2 Bohr magnetron. This one is going to be the general formula for this calculation of magnetic moment. Example, you see the case of titanium, titanium 3 plus. First you write the configuration for titanium. Titanium configuration, the atomic number is 22. Argon, you remove 2 electrons from outermost shell, 1 electron from the next shell, where I get 3d1. Upon number of electrons is equal to 1. Mu is equal to 1 into 1 plus 2 equal to 3. 1.732 Bohr magnetron. This is the Bohr type of questions. They will be asking in 2 or 3 1 questions. Next coming for about the stability, Fe2 plus Fe3 plus. This stable regarding iron, the atomic number is 26. Argon 4s2, 18 plus 2 20, 26. Fe2 plus na I have argon 3d6. Fe3 plus na argon 3d5. See here, in this stable half filled orbitals are stable. Adanala Fe3 plus is said to be most stable. That is comparison of stability. Next about regarding this F-block elements, when you come for the case of F-block elements, we have lanthanides and actinides. Now, next about this arrangement, that is which is said to be most basic, lanthanum hydroxide and lutetium hydroxide. Which is said to be most basic? This is mainly due to lanthanide contraction. Due to lanthanide contraction, we can explain about this problem, which is more basic, lanthanum and lutetium, and about the size. Here, lanthanum hydroxide is said to be most basic because regarding the size is said to be small, where basic character is said to be more pronounced, and that is the main reason. Here, the lanthanum hydroxide is said to be most basic than lutetium hydroxide. It's mainly due to lanthanide contraction. The size of lanthanide decreases from lanthanum 3 plus ion to lutetium 3 plus ion. Adnala we say that it is said to be most basic. Next coming for actinoids. Actinoids they are said to be man-made elements, which is called as synthetic elements. Europium 3 plus is more stable than cerium 2. Europium 2 is more stable than cerium 2. Europium you are having 4f7 configuration. Half filled orbitals also be there. And cerium we have 4f1 5. Yes, the next one is about actinide contraction is greater than lanthanide contraction. Why? Actinides you have electrons are filled in the 5f subshell. Lanthanides electrons are filled in the 4f subshell. Here, actinides oda shielding effect that is the 5f subshell has a poor shielding effect than 4f, and that is the main reason for the actinide contraction is greater than lanthanide contraction. Next about zirconium and hafnium. Why zirconium and hafnium exhibit this similar properties? This is also due to lanthanide contraction. Due to lanthanide contraction, zirconium and hafnium exhibit similar properties. About the position of lanthanides and actinides in the periodic table. Next about what is lanthanide contraction, give its effects. Comparison of lanthanides and actinides, the differences, just you go for that one, and variable oxidation state. These are standard questions, just you go for that. Next about coming for coordination compounds. When you come for the case of coordination compounds, ligands means they are Lewis bases, where they are said to be attached to the central metal atom. They are called as ligands. There are monodentate ligands, bidentate ligands, and this is based on the number of donor atoms, and we have normal ligands, that is neutral ligands, positive ligands, negative ligands. Neutral ligands, carbon monoxide, amine, water, that is aqua, they are called as neutral ligands. Chloride, sulfate, nitrate, fluoride, we say it's called as this negative ligands. And positive ligands, hydrogenium ion, it's said to be an example for a positive ligand. Nitrosonium is an example for a positive ligand. Homoleptic and heteroleptic complex. Homoleptic means central metal atom கூட ஒரே type of ligand attachment இருந்ததுன்னா அது homoleptic. CrNH36 that is homoleptic. Heteroleptic னா central metal atom கூட different ligands CrNH35Cl. Here two ligands are there, that is called as heteroleptic complex. Coordination number. Coordination number means the number of entities that is said to be present or attached to the central metal atom is called as coordination number. Next, about differences between double salt and complex salt. When you come for the case of double salt and complex salt, that is double salt when they have been readily dissolved in water and gives them specified ions. What ions are said to be there? Here it gives two forms of ion. One is the complex ion and another is said to be the normal ion. இதெல்லாம் வந்து about the double salt and complex salt. Naming of complexes, you go for that one. For example, K4FeCN6. K4FeCN6. In the case of K4FeCN6, first you name what type of complex it is. K4FeCN6. It is said to be a anionic complex. Anionic complex mean generally we start the naming only from positive ion. So it is potassium, hexa, cyanido, ferrate 2. This one is said to be the name of the complex. Similarly, CuNH34, SO4. This one is said to be a cationic complex. It is tetramine, copper 2 sulfate. This is about naming of complex. Next one. These are standard questions, the postulates of Werner's theory. You go for the primary valency and secondary valency, know the differences between primary and secondary, and that's about the postulates. Postulates of valence bond theory, and reason for the complex to be diamagnetic. Diamagnetic means if all the electrons are paired, it is diamagnetic. Paramagnetic means if it contains unpaired electron, it is paramagnetic. If it is said to be a paramagnetic substance, we can calculate the magnetic moment. காந்த திருப்புத்திறன் paramagnetic பாராகாந்த தன்மையாக இருந்ததுன்னா அந்த காந்த திருப்புத்திறன் கண்டுபிடிக்கலாம். டயமேக்னெட்டிக்னா அந்த காந்த திருப்புத்திறன் 0 பூஜ்ஜியம் ஆகும். Next one. Next, coming for solid state. When you come for the case of solid state, an important one is here about the classification of the solids and the what type of solids. For example, you see the case of phosphorus P4. P4 is an example for a molecular solid. Brass. Brass is an alloy. It's said to be a metallic solid. Diamond. It's said to be a covalent solid. Sodium chloride. Halogen ko alkali metal irukudhu. It is said to be a ionic solid. Iodine. It's said to be a molecular solid. Carbon dioxide, molecular solid. இதெல்லாம் வந்து some example classification of solids. And define unit cell and about the number of atoms in simple cubic. இதெல்லாம் வந்து you can go through it. Simple cubic இருந்ததுன்னா the number of atoms is said to be 2. Body centered cubic இருந்ததுன்னா the number of atoms is equal to BCC. In simple cubic it is 8 into 1 by 8 equal to 1. In BCC 8 into 1 by 8 plus 1 equal to 2. In FCC it is 8 into 1 by 8 plus 6 into 1 by 2 equal to 4. Regarding this simple cubic number of atoms are present only at the corners, that is called as simple cubic. Simple cubic means 8 into 1 by 8 equal to 1. Body centered cubic. Body centered cubic it is atoms at the corner and at the body center. 8 into 1 by 8 plus 1 equal to 2. Face centered, that is atoms at the corners plus atoms at the faces. We are having 6 faces equal to 4. That is the calculation of number of atoms in simple cubic, body centered and face centered. Next, about metal deficiency defect. You see that number of cations is said to be less in the case of metal deficiency defect. Bragg's equation, n lambda is equal to 2d sin theta, that is Bragg's equation. Characters of ionic crystal. When you come for the case of the characters of ionic crystal, they are said to be having high melting point, high boiling point. They do not conduct electricity, but they conduct electricity in molten state. We can say this about the characters of ionic solid. And what are F centers? Regarding F centers, that is responsible for coloration, and that is referred as F centers. That is, F centers mean where electrons are occupying in the interstitial position, they are called as F centers. Next, about regarding the formula used to calculate the density of the crystal and differentiate Schottky defect and Frenkel defect. And see, in the case of Schottky defect, the size of the ions are said to be more or less the same. The size of the ions are said to be more or less the same. Whereas in the case of Frenkel defect, the sizes are said to be different, and that is Schottky defect and Frenkel defect. Here, no change in density in the case of Schottky defect, whereas in the case of Frenkel defect, here also the ions are said to be occupying the interstitial position in the case of Frenkel defect. In Schottky defect, here the ions, equal number of cations and anions are said to be missing, that is called as Schottky defect. Example for Frenkel defect, silver bromide. Example for Frenkel defect is silver bromide. And for the case of Schottky defect, we say it is sodium chloride. Here in Schottky defect, no change in stoichiometry is said to be seen. So density is said to be decreasing. Density of the solid is said to be decreasing. ஏன்னா வேக்கன்சிஸ் இருக்குது, அதனால டென்சிட்டி டிக்ரீஸ் ஆகுது. ஆனால் Frenkel defectல பார்த்தீங்கன்னா அந்த ions are said to be occupying the interstitial position, அதனால density வந்து vary ஆகாது. That is about the Schottky and Frenkel defect. Just go for the differences between crystalline amorphous solids. Next about chemical kinetics. Regarding chemical kinetics, here the important questions are define rate law and rate constant, rate of a reaction and rate constant, elementary reactions and differences between order and molecularity, an important one that is said to be frequently asked. Coming for Arrhenius equation, K is equal to AE power minus EA by RT, that is Arrhenius equation. Just you explain the terms that is said to be involved in it. Half-life period means the time taken for 50% of the reaction to be completed is referred as half-life period, and show that for a first order reaction half-life is independent on initial concentration. For a first order reaction, T half is equal to 0.693 by K, and here we do not have any initial concentration term, and hence it indicates that half-life is independent on initial concentration for a first order reaction. Pseudo first order reaction, when any two reactants are said to be there, and if one of the reactant is said to be more when compared with the other one, then that is not said to be taken into account, and that is called as pseudo first order reaction. Inversion of sucrose. In the case of inversion of sucrose, you are having sucrose, you are adding water. Water is said to be in excess. So, excess reactant is not considered, and hence we say that it is an example for pseudo first order reaction. Example for zero order reaction, just you go for that one. Expression for half-life period of zero order reaction is a standard question. Expression for first order reaction, K is equal to 2.303 by T log A by A minus X, that is a derivative part. It may be asked in 5 mark question or 3 mark question. And then similarly, the rate law for a zero order reaction, based on this they will be asking some numericals. An important problem is the worked example problem. Show that for a first order reaction the time required is 99.9% completion is nearly equal to 10 times its half life. T 99.9 is equal to 10 times of T half. That is said to be, that should be proved. That is a worked example problem. Go for that one. Next, coming for ionic equilibrium. The case of ionic equilibrium, what are Lewis acids and Lewis bases? Go for the example for Lewis acid and Lewis bases. Lewis acid means they are said to be electron deficit. Lewis bases mean they are said to be electron rich, and that is the main difference between Lewis acid and Lewis bases. And conjugate acid base pair. Conjugate acid base pair means which differs by a proton, that is called as a conjugate acid base pair. Ionic product of water, concentration of H plus ion OH minus ion equal to 1 into 10 power minus 14 mole square decimeter power minus 6, that is said to be the ionic product of water. Regarding solubility product, just you go for the solubility product definition, common ion effect definition, relation between pH and pOH. pH plus pOH is equal to 14. From this we can calculate what is pH and pOH. A buffer solution. Buffer solutions are solutions where the solutions resist the change in pH. That is called as buffer solution. We have two types, acidic buffer and basic buffer. Regarding acidic buffer now, acetic acid and sodium acetate. Example, basic buffer now, ammonium hydroxide and ammonium chloride, that is basic buffer. Ostwald dilution law, with dilution the degree of dissociation increases. You derive a formula, alpha degree of dissociation is equal to root of Ka by C, that is the expression for Ostwald dilution law. For the solubility product of calcium phosphate, listen here, regarding for calcium phosphate, Ca3PO4 twice. You dissociate where we get 3Ca2 plus and 2PO4 3 minus. Here solubility is said to be S. KSP is equal to concentration of calcium 2 plus into concentration of PO4 3 minus 2. This is equal to 3s the whole cube, 2s the whole square, 27s cube into 4s square, 108 s power 5. That is the solubility product. And about the Lorentz-Bronsted concept, relation between solubility product and ionic product, and about this problem regarding the relation between solubility and ionic product. If solubility product is less than ionic product, it is unsaturated. Greater means precipitation takes place. Equal means it is said to be saturated solution. Yes, about Oxford dilution law we have discussed, alpha is equal to root of Ka by C. You take this Oxford dilution law is applicable only for weak electrolytes. Regarding Henderson's equation, pH is equal to pKa plus log salt by acid, concentration of salt by concentration of acid. And problems based on this Henderson's equation, the exam point of view is most important one. Coming for electrochemistry, regarding electrochemistry, here we are going to study about important question is Faraday's laws of electrolysis. What is Faraday's laws of electrolysis? Here M is equal to ZIT, that is said to be the first one, and the next one is said to be second law is said to be M1 by M2 is equal to E1 by E2, that is the second law about Faraday's laws of electrolysis. And about the factors that affects electrolytic conductance, go through its standard question. Equivalent specific molar conductance, it is said to be standard one. Why conductivity of solution decreases on dilution of the solution? Here conductivity of a solution decreases on dilution of solution because conductivity is said to be proportional to the number of ions. As dilution increases, you see that the number of ions per unit volume decreases. Adhanala we say that the conductivity of solution decreases on dilution. Next about this numericals, just go for that one. Coleridge law, an important question. Numericals based on Faraday's law and Nernst equation. Yes, the it's said to be standard questions. Just go for this one. Surface chemistry. When you come for the case of surface chemistry, you see that one, it's adsorption. What is meant by adsorption? This is a surface phenomena. In the surface chemistry, important question the difference between chemisorption and physisorption, a very, very important question. Chemisorption and physisorption. Now, when you come for the case of this in chemisorption, why adsorption first increases and then decreases with temperature? An important question. Peptidization. Peptidization means by using a suitable solvent or a reagent, we are converting into a precipitate, then into the colloidal form. Conversion of the precipitate into a colloidal form by using a reagent, that is called as peptidization. Difference between sol and gel. And then about Tyndall effect. Tyndall effect means that is whenever we view that is a zigzag movement of the colloidal particles is viewed with the help of an ultra microscope. About the continuation of Tyndall effect, when you come for the case of Tyndall effect means it refers to the scattering of light by the colloidal particles, that is called as Tyndall effect. Scattering of light by the colloidal particles is called as Tyndall effect. Brownian movement means the random zigzag motion of the colloidal particles that is said to be exhibited in the dispersion medium is called as Brownian movement. The random zigzag ceaseless motion of the colloidal particles in the dispersion medium is called as this Brownian movement. Now regarding active centers are centers which increases the efficiency of the catalyst, and hence more the number of active center, more is said to be the catalytic activity. Now coming for catalytic poison. Catalytic poison means the substance which poisons the effectivity of the catalyst is called as catalytic poison. For example, in the case of Haber's process, the synthesis of ammonia, here molybdenum is used as a catalyst. Iron is used as a catalyst. Molybdenum is used as a promoter. The catalytic poison is said to be hydrogen sulfide. Similarly, in the case of contact process, the formation of sulfur trioxide, where vanadium pentoxide is the catalyst, but here the main poison is said to be arsenious oxide, is said to be used as a catalytic poison. Now, next question about what is the catalyst characters, that is standard question. Promoter means which increases the activity of the catalyst. I have said in Haber's process, in synthesis of ammonia, iron is used as a catalyst, but molybdenum is used as a promoter. Yes, next about lyophilic, lyophobic, difference in homogeneous, heterogeneous catalyst. Yes, you go for that one. It's said to be greater for heat of adsorption is greater for chemisorption than physisorption. About electroosmosis, just you go for that one. Intermediate compound formation theory, adsorption theory of catalysis, a 5-mark question. Very important one. I have said at the start, difference between physisorption and chemisorption is a 5-mark question. Powdered calcium carbonate reacts readily with HCl than marble, because powdered calcium carbonate, each particle acts as an individual. So here in powdered form, the active centers are said to be more when compared with a full solid form, and hence they undergo readily reaction with dilute HCl. Or we can say powdered calcium carbonate has a large surface area compared to chips. So whenever the particle size is said to be small, the surface area is said to be large, and hence the rate of the reaction is said to be more. So it reacts readily with dilute HCl. And activity and selectivity of a catalyst, let's go for that one. Next about coming for organic. Here about this, in organic, you just go for hydroxy compounds and ethers and biomolecules. Some students, they feel organic is to be easy, and most of the students, they feel it's to be tough. So if you feel tough, you can go for hydroxy compounds and ethers and biomolecules. Now, regarding ionic hydroxy compounds and ethers, just you go through the questions that I have given here about preparation of alcohols from Grignard reagent, regarding primary, secondary and tertiary alcohols. When Grignard reagent undergoes reaction with formaldehyde, primary, when it combines with acetaldehyde, secondary, and ketone means it is tertiary. And then formation of glycol, Swan oxidation, and it's an important one. Similarly, when you come for the case of Victor-Meyer's test, it's also important. The primary alcohol gives a red coloration, second alcohol gives a blue coloration, tertiary alcohols gives no coloration. And we write this the example. Now coming for arrangement of alcohols in increasing order of boiling point. Generally, as the molecular mass increases, the boiling point also increases. That is the main concept. If chains are to be increasing, the boiling point decreases. And that is about the order of boiling point. And then Dow's process and preparation of phenol from cumene, that is synthesis of phenol, and 2 tests for phenol, just go for that one. And next is about the formation of acrolein, where acrolein is said to be formed when glycerol is subjected to treatment with P2O5, where we get acrolein CH2 double bond CH bond CHO. It is prop 2-ene 1-al, that is acrolein. Conversion of this propane, that is glycerol, into 1,2,3 trinitroxypropane, known as GTN, glycerol trinitrate, is an example where this CH2O, instead of hydrogen, NO2 group is said to be introduced, that is nitroglycerin. The products obtained when phenol is subjected to nitration using dilute nitric acid, it is ortho and para-nitro and nitrophenol, and they are said to be separated, that is the oxidized and reduced products of phenol is cyclohexanol and cyclohexanone. And standard question, formation of picric acid, it's not an acid, it is 2,4,6 trinitrophenol. And conversion to benzene, when phenol is subjected to treatment with zinc dust, we get benzene. Named reactions, an important one: Kolb's reaction, Raymer-Tayman reaction, coupling reaction, Thalin reaction, and Scott-Bowman reaction. Just go for that one. Lucas reagent, anhydrous zinc chloride and corn HCl. By using this reagent, we can differentiate the alcohols, whether it's primary, secondary, or tertiary. And the remaining questions, that is glycol to oxirane, ethanol, 1,4 dioxane, preparation of anisole, glycol on treatment with periodic acid. Important one is Williamson ether synthesis, where we can prepare this symmetrical ethers also to be prepared. And then conversion of benzyl chloride to benzyl alcohol and benzyl alcohol to benzoic acid. Problems from phenol. If C6H6O means, it indicates it is said to be phenol. Here, generally they ask problem based on phenol with coupled with Raymer-Tayman reaction and Kolb's reaction, and finally the phenol, when combines with ammonia, there is the formation of aniline, and from aniline they will be extending the problem, or else this A, B, C and D, that is enough. And coming for carbonyl compounds, Rosenmann's reduction for the formation of acetaldehyde, where acetyl chloride undergoes reaction using palladium and barium sulfate, where barium sulfate is said to be used as a catalytic poison and palladium is used as a catalyst. The formation of acetaldehyde is to be done. By using formal chloride, we cannot prepare formaldehyde because formal chloride is unstable. Name reactions, just go for that one: Stephan and Ettard reaction. Preparation, structure and uses of urotropin. Here urotropin means it's hexamethylene tetramine CH2 6N4, that is urotropin, and it's to be prepared from formaldehyde. When combines with ammonia, we get urotropin. Clemmensen reduction, Wolff-Christian reduction. In Clemmensen reduction, in both the cases, the CO group gets converted to CH2. In Clemmensen reduction, we use zinc amalgam, whereas in Wolff-Christian reduction, we use hydrazine in C2H5ONe. Haloform reaction, compounds having CH3CO group has a tendency to undergo haloform reaction. Just go for Perkin reaction, Navignol reaction, Claisen reaction. Formic acid reduces tolerance reagent because formic acid has a dual property. It possesses both an aldehyde group and acid group, and hence formic acid reduces tolerance reagent. The only acid that reduces tolerance reagent is formic acid. Test for carboxylic acid gives a brisk effervescence with sodium bicarbonate, blue litmus paper red. With alcohol, it gives a fruity smell, that is esters are said to be formed. Conversion of benzaldehyde to benzoin. Using alcoholic KCN, we can convert benzaldehyde into benzoin. Malachite green, it's a pigment where N, N diphenyl aniline is said to be used. When combined with benzaldehyde, we get malachite green. Cinnamic acid, C6H5CH double bond CHCOOH. HV reaction. In alpha carbon, halogens are said to be attached, where the reaction takes place in the presence of red phosphorus. Glacial acetic acid, 100% acetic acid. Benzaldehyde to benzophenone, benzoic acid. Oxidation of benzaldehyde benzoic acid. Kolb's reaction, conversion of benzene, Friedel-Crafts reaction, benzene to acetophenone, benzene to benzophenone. Friedel-Crafts reaction, acetyl chloride means acetophenone, benzoyl chloride means benzophenone. And 5-mark question, the mechanism of Cannizzaro and aldol condensation. Coming for nitrogen compounds, you make a note, that is for primary amines we have carbylamine reaction. This is a test for primary amines, carbylamine reaction, and very important one where there is a formation of isocyanide, C6H5NC, if it's said to be aniline, and CH3NC, it's said to be methylamine irundadana, this one is said to be the reaction. Regarding the electrolytic reduction of nitrobenzene, the various reduction products of nitrobenzene, a 5-mark question, it depends upon the nature of reducing agent. Gabriel Thalamate synthesis only for the preparation of this aliphatic amines and not for aromatic amines, because it does not, here aromatic amines mean we use an aryl halide, where aryl halide is said to be a center of electron density, and hence we cannot prepare aniline. Hoffman's bromamide reaction, diazotization takes place at 0 degrees Celsius, where aniline gets converted to benzene diazonium chloride. Chloropicrin means it is CCl3NO2, trichloronitromethane, where nitromethane undergoes reaction with nitric acid, where there is a formation of CCl3NO2. Nitromethane on combines with chlorine in the presence of sodium hydroxide, we get CCl3NO2, not nitric acid. Aniline does not undergo Friedel-Crafts reaction, an important one. Next is about aniline is said to be less basic than methylamine, because in aniline lone pair of electrons are said to be present, and here these electrons are said to be delocalized, and hence it is less available for protonation, and so we say that aniline is said to be less basic than methylamine. Ethylamine, the last question, ethylamine is soluble in water and not aniline, because ethylamine is soluble because it forms hydrogen bonds, but aniline does not form any hydrogen bonds. A mustard oil reaction, just you go for that one. Next about the last chapter, biomolecules. In biomolecules, just you go for the structure of glucose and fructose. Give any 5 to 6 points. Then what are anomers, what are epimers, what is epimerization, what is mutarotation, difference between DNA and RNA, what are reducing and non-reducing sugars, different types of RNA, and finally you have write a short note on lactose. Lactose means it is a mixture of glucose and galactose, where it is an example for reducing sugar, where the bonding is said to be, the glycosidic bond is between glucose 1 and galactose 4, carbon 1 and carbon 4, and hence we say that it is said to be reducing sugar. Non-reducing vandadana, sucrose is said to be non-reducing. Both the functional groups are said to be attached to the glycosidic linkage, and hence we say that sucrose is said to be a non-reducing sugar.